So this is we're hitting it at an elevation of 3.1 meters. And 3.1 meters, the key here is that you got to realize it's 3.3 meters down from the edge, because the whole thing adds up to 6.4. So you plug that in here, and then it's exactly the same thing we just did. My final velocity is going to be, the absolute value of it is going to be the square root of u squared, which is 0, plus 2 times negative 9.81, 2as. S is negative 3.3. So the square root of 2 times 9.81 times negative 3.3. I'm going to store that in V. So that is actually not the right answer. Hold on. It's interesting. Okay, let's go times 8.046. And then you have to put the minus sign on yourself, right? And then the time is going to be, I'm using 1/2 AT squared, so S is 1/2 AT squared. So the square root of 2 times 3.3 divided by 9.81 is what it ends up being. And then I can just go this times this. So here's our final answer, boys and girls. Varsity question number 1 is that he's 3.1 meters above the ground, 3.3 meters below the top of the cliff. He is 7.546 without sig figs, right? Meters out from the edge. I don't know why we care, but we do, right? His velocity over is 9.2. His velocity down is 8.0465, right? And then if you draw these things right, the actual velocity vector is actually tangent to the trajectory. So if you draw a trajectory like this, here the velocity is this way, here the velocity is that way, here the velocity is this way, here it's that way. That's obvious, isn't it? It's not a great fundamental truth. And then this thing is, we can find a magnitude and an angle if we go square root of 9.2 squared plus 8.0456 or 465. That apparently is 12.2 meters per second. And then this angle in here is the inverse tan of opposite, so 8 over 9.2. And that apparently is 41 degrees. It's adorable, right? Are we good on that so far? Varsity 1. So that's varsity question 1.